So I'm going to talk to you about the naming tools at ChemAxon. I'm going to start with how do I hold that?
Maybe not. I'll advance.
Okay, so I'm going to talk about the products that we have, which are structure to name. This is our first product. And then we have name to struct, and which is the other way. And document extractor, that's when you have a text document which have names inside, and you want to extract the names, and you want to convert the names to structures at the same time. So I'm going to tell you about those products, about the improvements, the new features, the hard numbers, about accuracy, and the past, the present, the future. And then the second part of the talk, Alex is going to show you the Chemicalize website, the shiny stuff. So next slide, please. So structure to name is the first product that we released for naming. It's pretty mature already, so as I know, it can convert basically anything reasonable you throw at it, something like 99.9%. It might not be exactly the name you wanted. In some cases, it might give you a longer name, but it's still some improvements in the last year. For instance, I added the handling of isotopes. You can see the first structure, it's acetonitrile with some deuterium atoms. Second one as well, it's a pointer. So that's the isotope 14 of carbon, and you see here in the name this superscript number. So now this is the name that's generated. Before it was just ignored. Here, this is some advanced stereochemistry. This is the pseudo-asymmetric stereocenters. Here we have two centers, and this also ends up in the name. So some small improvements. We have many more traditional names that you can generate. So it's an option. When you have a structure, you generate the name, either the strictly IUPAC name or more traditional, more popular ones. And now, in more cases, it will generate the traditional if this is what you want. And other features. So it's moving. It's already quite good, but some improvements. Most of the action has been in name to structure. So it's still something that's moving a lot. During the year, it was various versions of 5.3, and it's improving regularly. Every 1 or 2 months, there is a new release with a new version of name to structure in it. And we try to improve the coverage. So how many of the structures of the names that you give at it are going to be converted correctly? That's one measurement. The other measurement is how many of those that you get are actually correct structures. And so we try to improve both of that. We're going to see numbers about that. And it has been improving during the year, but we still felt not completely happy with the quality and with the coverage, especially the quality, actually. And so there has been recently a very major refactoring and rewriting of the name to structure. So I'm also going to show you some preview of the correction and the coverage in the next versions. So 5.4, which is going to come up in maybe 1 or 2 months, we'll have this major upgrade. Correction should improve a lot. Coverage will also improve. And that's something you won't see, but internally it's a much more modular architecture, and so it's going to be easier in the future to improve it. So let's see the numbers. When you measure anything, I guess, it depends a lot what is your data set. So we are going to look at 2 very different data sets. This one is quite systematic names, which should be easier, which means that they were actually generated by, not us, but a competitor, just to be fair. And so basically, it should be possible to convert those names back to structures. It's not always the case for any input that you have. So here we have 3 versions. You see in blue, this is the version 5.2.4, which was 1 year ago. And then the red one is the current release version, that's 5.3.8. It's what you can download right now and what you have on your pen drives. And you can see that during this time, this is the correctness on those systematic names. It was at 92, and it's improving very little. Actually, we didn't focus on that kind of names, but more the traditional ones that we will see in the next slide. So there was some improvement, but not so much. But in 5.4, we get the new architecture, and you can see that, well, this is a coverage, so we have a big jump. We have much more, so from 92 to 98, which is correct. And actually, the way we could get this improvement here is that we get the corresponding reduction of errors, so wrong structures in the output, from 7.5 to 2.5, so more than 3 times less errors. So in these names, it's a huge improvement. So you should upgrade to 5.4 as soon as possible. And actually, if you want to evaluate, you can also ask for us for alpha version, because that might be worth. These numbers, you can see that it's worth to upgrade as soon as possible. This is a different data set, which is mixed. It's various names. There are some traditional names. There are lots of names which are actually missing some things, or which have something in the name which is not in a structure. It's much more difficult. I try to account for that as much as possible in the test. But what is interesting is how many of those names you can convert correctly to the structure. And you can see that in these kind of names, already during the year, even with the latest version, we have quite a big increase. This is 50,000 in this data set, and we could convert more than 70,000. 5.4 can convert 80, so it's still an improvement. But more interestingly, the errors is going to change a lot. This is going from 27 to 25, and 5.4, big drop to 15. Those numbers, actually, you can see that this is not going to 0. That's because the data set is not very clean. So you could never get to 0. But you can see that the trend is very positive. So we have much better accuracy and coverage. And because of the new architecture, it's going to continue. This is actually very recent work in about 1 month. So in the next few months and during the year, the improvements should continue. OK, so we have to structure that's improving. On top of that, we have the document to structure product, which is something that you can throw at it text documents, text, free text, HTML, XML, and it's going to spot the names into it, and it's going to give you the list of those. You can access it from the API. You can access it from the command line. We don't have fancy GUI for that yet, but if you need that, we can see, or you can. Well, we have the API. So obviously, because name to structure is improving, then directly the document structure is going to improve at the same time, the quality and the coverage of it. But we still have a feature that many people requested, which is that you can actually throw a PDF document at it, and it will, if it's a text PDF, so not scanned images, but if it has text in it, then it will convert the PDF to text and find the names inside the PDF. So we hope it's going to be pleasing many people who requested it. And to summarize this part of the talk, so we have a structure to name, which is quite mature already, but improving as the years go by. And then name to structure, it's a lot of development, so watch out for 5.4 upgrade and ask for us for alpha version if you need, and report to us your experience with it. And also the command to structure, so you can apply that to your documents. You can now convert PDFs. And I'm going to hand the floor to Alex, who will tell you about
all right.
more of those.
Donate. Okay, you can hear me fine. I'll have to be quick. So that's all very nice, but how do you use it? So when we came up with an idea that let's just go straight in. So we made chemicalize.org. This is a website, a free public service we've made to chemicalize web pages and documents and anything. Practically, we're using the name to structure device and some technology we saw that lets you render the page exactly as you would do, but we just add some metadata in there, which is practically the chemical structures. We'll have a look in a minute. And we've extended that recently with seeing predicted properties of single structures. So all of our calculations are available, more or less, all of them are available now on a data page. And then sort of for the social networking kids, the idea here is that because when you load pages, there's a slight additional overhead in page load times, you're only going to use it, or chemists are only going to use it, and they're only going to use it probably on those pages that they're interested in seeing in a chemicalized format. So if we step back a bit, then the content, the URLs that Chemicalize has is what chemists are interested in. And I think that's pretty interesting. Okay, so yeah, what's in the box? Well, yeah, document extractor, Daniel's stuff. And then we've got some of John's stuff, the web services on search. That's something we've not quite added, but I've got a demo for you. And then the calculator plugins. And of course, we're still on the structures and the back end. It's not cartridge, is it? No, we're putting on just JChem base, isn't it? Yeah. Okay, so let's have a look. I'll jump over to the demo, and hopefully it won't all go pear-shaped. But this is ChemAxon landing page. This is where the action happens. How do you get your structure in there, or your name? Well, you can paste the name. You can upload a file, and all of our file formats are supported there. You can also just like pop Marvin open and either paste the name or draw the structure. And then this is really light. The rest of the page is pretty light because this is where a lot of action is going to come. But I'm rather letting you guys populate it, and then we can start doing interesting things here. But this is going to be, I'd like to think, the journal of current online internet chemistry. So lots to happen there. So let's do something cool. This is list of organic compounds at Wikipedia. I copy this URL and paste it in here, and we chemicalize it, and it works. And you can see that the page looks just the same, except we've got this box at the top, with the exception that there are some now dotted underlines here. And anywhere you see dotted underline, we've identified that as a chemical structure, and we've popped into the HTML, the structure image. So that's nice. If I click on links, because these are also links, it's important to notice that the whole session is going to be chemicalized here. So I'm picking up and chemicalizing the next pages. There are some issues we have with that, but that's where the browser plugins come in, and we're developing those also. So that's browsing about and also populating our database. What else can we do? So, well, actually, I'll just skip back quick. Let's do something really cool, I think. Let's misspell enanapril. Is it going to give it to me? Well, number one, we've got, this did actually work. Yeah, so we've put some cleverness into auto suggestion here, and we have some choices here also. But if we just stick it in as it should be spelled, or we choose this one, it's not final yet. Then we come to the data page. This is the shiny bit, yeah. It's really funny because these are all toolkit guys, they're real dry, and then all of a sudden they're making some shiny things and people are saying, that's really great. And it's like, well, it's really sad actually because all the hard work's in making the predictions. So anyway, so what we've got here is all of the calculations that are currently available inside the ChemAxon technology. We can add and remove them. We have some preloaded templates to let you sort of quickly have something to look at. Things of note here, this is a bit of an awful low-res screen, but things of note here is there is quite a lot of shininess here, and I think it's pretty useful. For the heavy calculations, we make them on demand because we just don't have the servers to do this. It's a free service after all. I mean, we have to notice it's .org, so that's something to note. We don't think this will change anytime soon. So just having a quick look at what we've got, just some sort of fun stuff here. Notice that the chemical terms make it here also. So we're able to do this sort of stuff. And this is another way that we can go forward in the future, let people play here too. So this is the data page. This is what we call the data page. This was very recently added. Let's go back. Just finish off looking at these screens. You've seen this. I would like, and this is pretty much the service as is now. But what we've got under the hood is search, of course, because we do search rather well. So let's pop over to the alpha and hopefully not get stung. So this is your default search landing page. This is still under development, so it probably won't look quite like this, but I like this already. So the idea here is that Marvin has a bit of overhead, and images here are pretty cheap. So we use the structure image to fuel the next search. So here we have our different search types. We can fire this, and even from here we can see websites that we have, multiple websites for, in this case, this structure. So let's, well, I don't know, I shouldn't really do a search, but let's try, well, actually, let's try an Allardyce. So this is our search result. We've identified, we've highlighted this structure cutely. And so this we would have only one search result for this, because we only store this one structure. But where we have options is on the links off from this structure. So these are the sites that have been visited by the users already where an Allardyce has been identified. And some other nice shiny stuff for you. You want to see chemical structures, I think. So we put these here. And Mitsu tells me that we have a nice cheap tech to put N structures representing any number of size set. So if you had 1,000 structures, and we've got some kid on Google Docs with 90-odd thousand structures on a public spreadsheet, and he's chemicalizing it crazy. So we've got a lot of structures in there now. And I think, yeah, seeing the structures is what you guys want. We have this diversity analysis. I think other things, mainly for the landing page, just to finish off, let's go back to the landing page. And, excuse me. I'm really interested in extending this up. We have a lot of technology, maximum common substructure clustering, for instance, tree diagram viewers for search results. All of this stuff is in hand, and I've got some leash and a very skilled developer, so we can implement here. And we've even got the ear of John, so we can get features out of web services that serve this. I mean, hopefully you're thinking, why are these guys doing this? Because we're pretty much, with the data page, we're pretty much commoditizing the whole market around about there. But we're doing it because we believe in it, and I think it's crazy useful, and I think we should all benefit. And ultimately, I think this landing page has a lot of potential to be like something you might want to pop in and visit now and again just to see what the world's getting up to there. So yeah, this is the service. It's moving pretty quick, totally driven by you. It's not the same as the products because it's not quite the same. But I think it's doing enough now to be worthwhile to start making noises about. As I say, it's a .org, so I think it's going to be there for quite a while. Please try it, use it, work it, link to it. It's there for you, so enjoy. Thanks very much.
It looks pretty cool. And one question I had is you mentioned this. You said something about ways of getting data in our database or the database. So it wasn't clear to me, when you chemicalize a page, do you then start populating a database of the structures you found there, or do you actually have to proactively say, go load these?
No. We thought about it. You know, I spoke to Tony Williams about getting ChemSpider on it, but that sort of defeats the point. I'm going to have 30 million potentially rubbish molecules, which I don't know if people are interested in or not. You know, it's human web crawling technology. That's what it is.
Right, but so to answer the question, yes, we do populate the database from what people chemicalize. And that's why when you search for a structure, you can say which web page does contain this structure.
But that's all we store. We don't store the calculation results. So every new version may be whole new data.
So I like this feature with an Allardyce that does the correction. I was wondering about that in the named structure, if you have any error detection. And specifically, I'm thinking of cases in the past I've had where you do optical character recognition on a PDF, and it does funny things like parentheses and capital C's, and you can look at it and you know what it's supposed to be, but it's really a pain to get it into something that, and I was wondering if you thought about that or have anything like that.
Okay, so can you hear me? Yeah, okay. So in document extractor, we have OCR correction phase. So we actually, if there are some extra spaces or 1 instead of L or L instead of 1, this kind of things is, we try to fix it. It's a very hard problem because any different way to scan or we'll have different things, but we do that. We could do something about misspelling if the name actually comes from the dictionary. If it's a systematic name, it's going to be very, very hard. But so at the moment we have OCR correction if you use documented structure, not if you use name to structure, but it could be done. And we could also do that on a dictionary. It's done on chemicalize independently of that.
So maybe you said that does the name to structure support conventions other than IUPAC, like INCHI or CAS?
Yeah, we do support IUPAC and CAS. INCHI is supporting as well. It's a completely different part. But so we also support the format of INCHI, of course. Yeah. And so it's not going to be done by name to structure, but because you have automatic file format recognition in Marvin, then if you like paste something on Marvin, for instance, it will. If it's INCHI, it will work. If it's a name, it will work. Yes.
And so on in batch.
Yeah.
Yeah, you can do in batch.
And does this work only on HTML, only on web pages, or does this also work on like PDFs and other things?
Yeah, well, I haven't actually mentioned it to Chizzy yet, but now that we have PDF extractor, actually, this is a question for you guys, yeah? The trick here is everything's public. And when we've got a lot of searches, I rather fancy letting people search searches. And if you could drag a PDF over the site and let go of it, how would you feel if I presented the whole content of that PDF as a linked result and somebody found it later? I don't want to stop people using it, but if I PDF something, chemicalize a PDF, then I can't link to it as a result if I don't have any context or anything to actually show. So I'd like to actually keep it. But as long as I think if I make you understand that that's what's going to happen, then you use it at your own. I mean, big pharma guys aren't going to touch this. I mean, you're going to buy it and put it in-house or build it yourself. So this is really a public service. So I don't want to have people catch me later. I'm really interested because I don't know where it's going to stop you using it, and that's what I don't want.
You add an anonymous option. You add a check box for anonymous.
Yeah, I know, but if we said, would you guys like any feature, you don't put your hands up. So everyone will just go anonymous, and then I'm lost again. And I've got a whole bunch of cycles.
Well, you can make anonymous not the option.
Yeah. I'll make it hard. Yeah, okay.
One last question.
A question for structure to name. Do you think of having a batch version there?
We do have a batch, yeah.
You already
Yeah, for the batch you need a license, either academic or you need to buy it. But so you can use structure to name on the sketcher. You can actually have the name printed in the sketcher, and as you update the structure, you will see it updated in real time. That's the non-batch version. And you have the batch version with mol converter or the API or in instant JChem as well. You can convert your structure to name. So we have the batch, yes.
Okay.
Thank you guys very much. That was very enlightening.
Okay.
Just one comment. You actually you can use this if you put a parameter after like a name of a structure or a smice or anything, it will give the same result. So you can send it in an email to a colleague.